I think this would be a good time to resume for our afternoon session. Um, Thanks for joining us, and I'm very happy to introduce John, who will be talking about Copernican ground. So, do you want me to let you know, like when you have 10 minutes left over? You have an hour, I think? 60 minutes? So,
50 or something, but let's see.
I mean, if you,
Yeah, I probably won't succeed, but I'm aiming for 50.
okay, if you don't, I'll let you know.
Okay, perfect. Okay, thanks so much for inviting me. It's been a pleasure to be here. It took me a while to get here, but it's been great once I finally got here. So I'm going to talk to you today about a project I've been working on for a very long time. So the handout is extraordinarily long. I'm not going to try. It's almost a paper, anti-handout maybe. So I'm not going to try to go through all of it, but I'm trying to give you the main ideas. Okay, so let me begin with two problems that have exercised me for a very long time. So when I say something in English like Litland tends to go on for too long, the very same thing, the very way the world is when that's true is the same as when I say in Norwegian Litland bruker for mye tid. The different sentences in different languages can express the same proposition. That's the thing. And now what are propositions? So one of the topics for today is structured propositions. So you can think of propositions as being built up by applying properties to objects, relations to various objects, and so on. Theories of structured propositions hold that the proposition you get when you apply a property P to A is the same proposition as the one when you apply Q to B, if and only if the properties are the same and the objects are the same. So that's the theory of structured propositions. Really quite popular in the philosophy of language. Nathan Salmon, Scott Soames, so on and so on. But there's a problem with this theory, which has sort of been brought to light already by Russell, but much more again recently, and I would like to think of it this way. It is that the theory of structured proposition is simply counter-Cantorian. It contradicts a higher order version of Cantor's theorem. So let's just very, very quickly look at that. So if we have propositions, we also have properties of propositions. So now so let Q be some proposition. And then you can define a function f from the properties of propositions to the propositions simply by saying f of p equals p of q. Okay. Very simply, it just takes the property propositions p to the proposition that q is p. If propositions are structured, that's an injection from the properties of propositions to the propositions. Well, you can't have that, or so people say, because you can prove a higher order version of Cantor's theorem. Okay, so that's bad. So that's a counter-Cantorian consequence of the theory of structured propositions. Recent work, when people like bang on about the Russell-Mayel paradox in higher order metaphysics, in effect, they're just pointing out this counter-Cantorian consequence of the theory of structured propositions. Okay, so that's one thing. The other thing is, I am obsessed with ground. So what is ground? It's the notion of metaphysical explanation. Something is the case. You may ask why or in what that's being the case consists. The answer to that are the grounds for that thing. Many people are interested in ground, explicitly take ground to be a relation between things that are essentially like structured propositions and propositions. Those people are counter-Cantorians, whether they want to or not. But even if you don't take the relata of ground to be structured propositions, you can actually prove that certain standard principles in the logic of ground actually force there to be an injection from the properties of propositions to the propositions. And so the theory of ground is also counter-Cantorian. I'm not going to go through the proof of that, but happy to ask for that during the Q&A. Sorry, let me just say one thing now. I'm very happy to take questions throughout. If they're substantive, I'll postpone them, but ask anything clarificatory at this point. Okay, so what are we supposed to do with this? Well, if you read the higher order metaphysics literature, they say like, well, so much the worse for structured propositions and so much the worse for ground. I have 10 years, so I'm not so worried, but if other people should work on something else. Anyway, I'm actually going to suggest we should accept these counter-Cantorian consequences. I'm going to develop for you, or sketch anyway, how one can develop a consistent, and by which provably consistent, I should say, theory of structured propositions based on ground. That is counter-Cantorian, and I'll try to make sense of this counter-Cantorianism. Let me just say one thing here, which is not on the handout. I don't want to deny Cantor's theorem for sets, so I do really think that the power set of a set is larger than that set. So this is counter-Cantorianism about properties and propositions, not sets and power sets. Come back to that later, maybe. Okay, so now a notational thing. I hope I can avoid this for as long as possible. We have to make a choice about how to think about the relation, how to formalize claims of ground, and I'm going to do it like this. In the theory I'm going to develop, there will be certain special properties, what I call extensional properties. You should really think of these as pluralities, so there'll be extensional. So, sorry, an extensional property is a property which not only applies to exactly the same things in all circumstances, but which is such that if two extensional properties are applied to exactly the same things, they're in fact the same property. So extensional properties are like Phrygian extensions or like pluralities of things falling under a concept. Okay, so I'm going to take the relation of ground to be a relation between extensional properties. I'll write these as uppercase x's and y's and so on, and then propositions. So we're going to write xx grounds p, sorry, x grounds p rather, to mean that the propositions that have this property ground p. The notion of ground I'm going to be interested in is what's known in the lingo as non-factive immediate ground. So it's immediate in the sense that it provides the most immediate explanation of that which is ground. So each disjunct grounds the disjunction. So let me give you the standard example. So the disjunction P immediately grounds P or, let's say, P and Q. But P, Q together, let's write it like this property only immediately grounds P or P and Q. Why? Because these two immediately ground the conjunction, and the conjunction and in turn immediately ground the disjunction. But that's the notion of ground we're going to be interested in, immediate non. Oh, and it's non-factive in the sense that P needn't be the case in order to ground this. You can probably finesse that, but it's more convenient to work with that notion. Okay. All right, so that's what we're interested in. And now, bottom of page 1 of the handout, twofold fundamentalism. Okay. In the grounding literature, many people defend fundamentalism or foundationalism in a certain sense. Every proposition that is the case is immediately grounded in some ungrounded propositions. Propositions that do not need themselves to be grounded. If they obtain, they just do. No further explanation needed. And everything else is grounded in one of those. Okay, so that's grounding fundamentalism. So I'm interested in a second type of fundamentalism, namely what I guess should call definitional fundamentalism. There are certain things that are indefinable. They are what they are. There's no further explanation. Everything else is defined in terms of them. But how does this explanation work? What I'm tempted to, well, what I'm going to defend today is that at least for propositions and properties and relations, the definition goes by way of specifying what I call grounding profile. The contribution a relation makes to how propositions formed by applying it are grounded. Okay. If you don't like ground, substitute truth conditions for this. So how do I define a property? Well, I specify the contribution it makes to the truth conditions of propositions formed by applying it to some relation. So that's division. So that's twofold fundamentalism. Okay. And we're going to get clearer later on what I mean by grounding profiles and so on. Okay. And now I have to say something which is one of the places in this project where I sort of go back and forth. Every year I do it a different way. So today is negation week, so we're going to do it the following way today. People are interested in ground and people are interested in truth-making semantics always have an embarrassment on their hands because we don't really know how to deal with negation. Or maybe we do, but we're not quite comfortable with how we deal with negation. The standard way of doing it in ground and truth-making semantics is that you do it bilaterally. You specify the truth, in truth-making semantics, specify the truth makers for proposition, and then you specify the false makers. In terms of ground, you specify the grounds for proposition, and you also specify the grounds for its negation, or if you prefer, you specify the anti-grounds for the proposition. So that's what I'm going to do today. So in effect, you now look at a bilateral story here, where you specify, not in terms of refutation and assertion now, but in terms of ground and, if you like, anti-ground. So that's what we're going to do. So that means that in specifying grounding profiles, I also have to specify anti-grounding profiles. And that's going to complicate the story at various points. But let me give you some examples very, very quickly about what I mean by a grounding profile, since I just forgot this. My go-to cases here, because they're so simple, are conjunction and disjunction. So conjunction and disjunction are both relations between propositions. So conjunction applies to two propositions and yields a third proposition. What's that proposition like? Well, it's the proposition that's grounded in the conjuncts, right, taken together. Disjunction is also a binary relation between proposition. How is the resulting proposition grounded? Well, it's grounded in each of the disjuncts, as it were. That is what conjunction and disjunction are. They're specified by the grounding profile. Anyway, that's the story. We'll see about how it goes. When you deal with negation, you have to say something about this, because now I know the grounds for a conjunction, just the conjuncts taken together, but what are the grounds for the negation of the conjunction? Well, the standard story is it's the negation of one conjunct, negation of the other conjunct, and then maybe just the negation of both the conjuncts. Okay, so we have to say something about what the grounds for negated propositions are as well. So we have to do two things. We'll come back to that as we go on. Okay. Okay, we'll come back to this afterward. Okay, so now here's the main problem with this view, or any view of this form, is that it's very close to paradox, right? So let's do a very simple case, like there might be constituentless propositions that just don't have any constituents, and they can be defined just by specifying how they're grounded. So let's look at the proposition R, which is grounded in all and only the propositions P such that, and you can probably see what's going to come, P doesn't immediately fully ground itself. That's the Russell proposition. It grounds itself if and only if it doesn't ground itself, and you have paradox. Okay, you can't have that. Well, you know. Maybe I should rescind my membership at this point and say, actually, of course you can have that. But I'm going to be unorthodox in a different way. Okay, so we'll see. Okay, we can't have this. Okay, so okay. We'll have a different heresy today. Okay, so how can we avoid a grounding profile like this? Well, here's a very natural thought, the one we're not going to take, and it's just to model things on the iterative conception of sets. So how do we do it? Well, we think of a proposition pretty much as the set of its grounds. On the iterative conception, you can only form a set after you've formed all its members. That's why you can't form the set of all non-self-membered sets, because there's no stage at which, in the construction of sets, where you form all the non-self-membered ones. That's why, and that's how you can avoid paradox. And similar thing here, if I can only form a proposition after I already formed its grounds, well, I can't form these propositions because non-self-grounding propositions are co-final in the hierarchy of propositions. Okay, so we could do that, but we're not going to do that. Why? First of all, because the talk will be short, but okay, it wouldn't be that short. There's lots of details, but because I think it's really stultifying. You couldn't, on this view, so here I talk just about propositions, but I want to do this for operations and propositions. If you did this, you couldn't actually form an operation or a relation of conjunction, right? Because conjunction, if it's a relation between propositions, will have to take two arbitrary propositions and yield a third, which is going to be grounded in exactly them. But that relation has to be defined at some stage in the hierarchy, but at no stage have you defined all the propositions, you can't actually get conjunction. So what you'll get is like a hierarchy of different conjunctions. If you're interested in this, I think kind of what you get if you do this way is something like a very, very serious version of the ramified approach to propositions. So we're going to do something differently. And this is the point where I take the Copernican turn. So let me explain what I mean by the Copernican turn. I'm going to erase this. I'm going to draw a different kind of picture. So I'm going to illustrate Copernicanism. So So this is not my turn. I mean, I'm not bold enough to suggest that what I'm doing is a Copernican revolution in philosophy. Kit Fine has no such scruples, so let's blame this on him. Okay. Anyway, so he developed a theory of classes, really logical classes, which was Copernican. So here's the metaphor, a good metaphor, I think. On the iterative conception of set, you take the membership relation as fixed. You know what membership is, but you don't know what the sets are. So the ontology of sets keeps expanding no matter which sets you have. You can form a new set by reflecting on membership. Okay, so as it were, membership is fixed and the ontology revolves around membership. That's the pre-Copernican view, for sets, I should say. Okay, now the Copernican view for classes says things are different. The ontology of classes is fixed, already given at the outset. What's not given to us is membership. And I'm going to use not set membership here. I'm just going to use an eta for the relation of being a member of a class is gradually revealed in a number of stages. So at the first stage, we know we have access to all the classes, but we don't know which are their members. And then we're going to iteratively expand the membership relation in a hierarchy of stages. So the ontology stays the same, but I guess what Kit used to call it, we have an ideological expansion where we gradually build up the membership relation. Okay, so how does this work and why is it consistent? Think of it like this. You're starting off with some knowledge of membership. And then you have a bunch of classes here. They're there, you can quantify over them, you can say that this class is distinct from that class and so on, but you don't know what their members are. So the classes you don't have access to yet are like black boxes. And then we're going to ask a bunch of questions, and then gradually we'll open up more and more boxes. At the end of this story, we'll have opened up all the boxes and we'll have full knowledge of the membership relations. Okay, so how does this work? At stage 0, I'm going to put this up here. This process takes place in a number of orders. So we're going to have a claim which says like this, for all orders O. There's going to be a class which is going to occur at the next order. I'll explain what this means in a second. So for all x, x is going to be in the class C if and only if phi of 0. Okay, so what is phi of O? Take any claim you like in the language of this theory, so it can be having a number of things, but you're going to restrict how the membership relation figures here. So whenever you take phi and you transform it into phi of O by replacing x's and y by x is in y and y is in O. Okay, so you can't. So instead, I can define a class, but in defining it, I have to restrict the use of the membership relation to classes that have already been revealed. Okay, so what's cool about this is you immediately get a universal class, right? Because the universal class is just defined by the condition x equals x. There's no use of the membership relation here, so I have nothing to define. So already at the first order, you're going to get a universal class. And the universal class is going to be a member of itself. So you're going to get a lot of self-membered classes on this theory. You are going to get that if we have a class C, which is, say, defined by phi of O, then the complement of C is defined by, well, not phi of O, which is also restricted if phi of O is restricted. So the classes will actually form a Boolean algebra. In fact, I think it's a cylindrical algebra, so it's kind of a nice theory of classes to have around. Okay, so that's Kit's theory. It's been developed further by Øystein Lindeboe and especially Sam Roberts. Can be made to be very, very strong, actually. But that's not my theory, because their theory is a theory of classes, but the idea of the construction, namely that you're going to restrict, so if, in a sense, in the pre-Copernican view, you put no restriction on comprehension, but the classes you form can only have members from the previous order. Here you put no restriction on what the members of the classes can be, but you put a restriction on the comprehension formula. It has to be class restricted. I'm going to do something similar for grounding profiles, and that's how I'm going to avoid paradox. So, so that's the idea. Very, very nice idea, I think. Anyway, let's see if the development is nice, but here's the idea. Okay, so now things become a little bit harder. Let's see, we're looking for time. Okay, so we're not going to go through all the messy details. I'm going to wave my hands at them. So let's go write this picture down again, but in a slightly different way. Okay, so on Kit's theory, we are at some order here. So for me, I now have the grounding relation, which is revealed, and I have all the propositions that I don't know anything about yet. What does it mean that I don't know anything about them? Well, I don't know what their immediate grounds are. That's what it means that I don't know what they are. Okay, so for Kit, he's just looking at classes. So for him, the classes are black boxes. So I can see that two black boxes are different. Well, after all, they're different boxes. But I don't know what's in them. And that's all he can say. But for me, I can say more. Because even though they're black boxes, as it were, they're black boxes of different shapes. So I can see that there's a black box that looks like this. What does that mean? Well, it's a black box that has the form of a binary relation applied to two relata, in that order, maybe. And then I can see, here's a different black box. This is maybe a ternary relation applied to three different things. So I can see that these are different. They're built up in different ways. And they have different arity. But I don't know what grounds them, but I can at least see that they are structurally different. Okay, so let's try to make this idea of differently shaped boxes precise. Okay, so that takes us to Copernican ground theory on page 4 of the handout. Bit of water. Okay, so next step in the theory is we need to be able to talk about the structure propositions. So what's the sense in which propositions have parts, and so on. Well, I'm going to deal with this in an operational way, so I'm just going to assume that we have a bunch of application operations. We're going to write them script A. Well, we have infinitely many of these, I should say. It takes a relation as the first input. Takes some, we'll come back to what it means that takes a relation as first input in a second. Takes an n tuple, well, takes n things. And then we have this. This means that P is the proposition that results from applying R to A bar in that order. Okay. So that's the basic way we're going to talk about mereology. So the basic notion is a whole forming operation, and the basic notion is that is not the notion of part. The notion of part is defined in terms of whole formation. It's kind of hard to make sense of propositions. Are, if you have non-symmetric relations, like I am taller than my brother, it's very hard to make sense of the structure of those propositions just using the notion of part, because like me and my brother figure in different slots as we're in this position. Okay, so that's why we do it this way. Okay. We need to say a little bit more about this operation. We need to say when it's defined and what its identity criteria are. Okay. So here's the when it's defined part. Conjunction for me is going to be a relation. I shouldn't get anything if I apply conjunction to me and the cell phone. Maybe I should get something if I think of like objectual conjunction, but propositional conjunction, I shouldn't get anything. Okay, so what we're going to do is we are just going to spot ourselves a bunch of sorts. We have sorts. We have a basic sort I for individuals or objects, and then if tau naught to tau n minus 1 are sorts, then this thing here, of course, is now a sort. So notation here looks very much like the notation of relational type theory. That's from the knowledge. It's not typed. So you could do it typed if you want. I don't want to do that. I'll talk about that in a minute. Similarly, we're going to have a different sort, and that is the sort of relations in extension. So we have two types of relational sorts: extensional relations and proposition and sort of regular relations. And this, as usual, is the sort of propositions. And then we're just going to add to our language a bunch of predicates as tau for is of sort tau. Okay. And then we're going to say the kind of obvious thing, namely that if this is of a relational sort and these are of the appropriate sorts, then there is a proposition formed by applying. So you just say the obvious thing, but you need to add that. So in the theory, you'll just add a bunch of axioms to capturing exactly that. Okay, there are some details to be worried about here. And then you can avoid, since conjunction is a relation between propositions, and me and my cell phone are not propositions, then okay, we get the result we want. Okay, and then finally, this is not that important. We need to say when things are identical. Sorry. Oh. So when is the proposition P both the result of applying R to A's and R prime to the B's? Well, then R are the same and the A's are the B's. Okay, so obvious. This is actually, I don't think is the right answer, but we need to start somewhere. And the reason it's not the right answer is that this forces me to distinguish. Yeah, I mean, you can see P and Q is distinct from Q and P. It's not great, but you know, if we can make an excessively structured theory consistent, we can work this out afterwards. But I just want to flag that for now. Okay, good. And that skips us far ahead. And then, okay, I'm going to skip really far actually. Happy to take questions about the grounding structure stuff, but it's essentially there just for showing that I've done some of my homework anyway. Okay, but let me try to talk you through what's going on in this grounding structure. So let's go back to this picture. Here we are. So a grounding structure really looks like this. But now the sorting predicates and the application relation, that caches out the idea of the differently shaped boxes, right? So what is it for a box to have a certain shape? Well, it is for it to be the result of applying a relation of a given sort to some relata of the appropriate sort, so that caches out that metaphor. The grounding relation, well, that is just a relation between certain extensional properties, which we have here, and certain other things. So that's the story. And then we want to, but now a grounding structure now can have certain pathologies. So there are two pathologies that can come up. One pathology is that we have some propositions that haven't been assigned any grounds at all, and we actually haven't said that they're ungrounded either. Right? So the picture I started out with, sorry, I should be clear about this. Okay, let me take that back. The main pathology you might have is that you might find yourself with two relations R and R prime, such that for all A and B, these have exactly the same grounds. Okay, so you might, for all we said so far, find two different relations R, so things of sort relation, such that for any two objects A and B, the proposition you get by applying R to A and B has exactly the same grounds as what you get by applying R prime to A and B. Okay, and that is like technically just fine, but the spirit behind the view is that you define relations by specifying their grounding profile. So if you ended up, just one second, So if you ended up with two relations with the same grounding profile, that would not be great for the picture where relations are individuated by specifying the grounding profile. Yes, go ahead.
Okay, what do you mean is possible grounds, like not actual?
Yeah, possible. Yeah, sorry. Yeah, I should be clear about that. So this is the place where non-factor ground is really helpful because, of course, very many propositions that are intuitively distinct will not differ at all with respect to their actual grounds. In particular, that happens if the propositions are false, because then they don't have any grounds. And you don't want to say that all false propositions are the same. Maybe you do, but okay. I don't know. So yeah, here it really matters that you work with non-factive or possible grounds. And actually, this is also a place, honestly, where the treatment of symmetric relation gets a little messy because there will actually now be two conjunctions here, but this can be finessed. Okay, so what we want to show for the theory is that, so there are two aspects. We want to write down a theory of how this works in the object language, that's the main thing, and then we want to prove that that theory is consistent. How do you prove that it's consistent? Well, that is by showing how you can come up with grounding structures that are on what I call full and individuative on the handout. So full means every proposition either has some grounds or has been said to be ungrounded, and individuative means you don't have two relations, such that the propositions formed by applying them to the same relata always have the same grounds. Okay, and how do we do this? There's a lot of annoying details here. But the basic idea, and this is, skip really far ahead here, page 11 of the handout, skip many pages. Please ask about the details afterwards. You can embarrass me by forgetting my own theory. So in Fine's theory, I said that in Fine's theory of classes, the classes come in different orders. Okay? So what are these orders? Actually, it turns out you can identify the orders with certain classes. So which classes are orders? Well, suppose you are at an order. Now you can identify that order with the classes that have been defined by that order. So suppose I'm at order O. I identify the order O with the class of classes that have members at order O. That defines it. So when you axiomize the theory, you have to add a predicate for this. What I'm doing here, so my theory is a theory of propositions, and what we gradually expand is the relation of ground. So at any stage, so you develop this in a hierarchy of what I call, I keep flipping between orders and stage, I should say order. At any given order, certain propositions have been assigned grounds. You can identify that order with the proposition that is grounded in those and only those propositions that have been assigned grounds at that order. Okay. So here's the idea. At order O, we have the grounding relation restricted to order O. At the next order, we have the proposition P defined by for all R grounds P if and only if there are some x's such that x grounds in the sense of O are. So that's the idea. You identify. So as you go through the construction, you have various orders. At each order, the grounding relation, you have this much knowledge of the grounding relation. At the next order, you can now define a proposition, the grounds of which are exactly the propositions that have grounds, or I should add, have been settled to be ungrounded at the previous order. And that is going to be, within the theory, the propositions that represent the orders. And then the propositions that are ordered propositions will actually be well ordered by the grounding relation. So that's what we're going to add to our theory. Okay, so this goes very fast. So let me see what we're looking at for time. We need to apply this to something too. So let me just say what the key axiom of the construction is. And say one thing here. I'm doing everything in terms of ground, but that's not quite right, right? Because I said, oh, I'm a bilateralist about negation, so I can't just ask what grounds the proposition form by applying R to some things. I also need to say what grounds the negation of those propositions. So I really need to not just talk about the grounding profile, but the negation grounding profile. And those need to be coordinated appropriately, but let's skip over that. Okay, so what is this theory like? Orders are propositions. So we know what it is for a proposition to be in an order. That's just for that proposition to ground that order. Right? Because orders are just certain propositions. But there are other things too, relations, what have you. And we want those guys to also, in some defined sense, occur in an order. Here's how we're going to define that. R occurs in the order O if and only if, and this is now a schematic claim, fortunately, but that's how it goes. There are some relata and some propositions such that the result of applying R to those guys is the proposition P, and the class, or, the extensional property which applies just to P grounds the order O. So this looks messy, but it's the intuitive idea. A relation occurs in an order if the propositions you get by applying it to some things occur in that order. So a relation is there, occurs in an order if the propositions you form by applying it to any things occur in an order. In that order, I should say. Okay. All right, so now there are various axioms that sort of describe the construction. The key axiom, it's in a mess on the handout, so I'm going to try to do the simple version without exclusion. It says this, let's see if I can do it correctly. For all orders O, there's going to be a relation R, and where this means now there is an entity which is of sort of this appropriate type, which occurs in the next order, and this thing is, say, of sort sigma tau R, and for all A, for all B, what a mess. Yeah, sorry, this is all the stuff. Okay, good. If the result of applying R to AB equals P, then for all X, so this is the grounds for X, the grounds for P are exactly the X's such that gamma O applies to A, B, and X. So the way to think about this is a formula which holds between something A and something B and an extensional property X, if and only if the proposition you get by applying R to A and B in that order is exactly grounded in X.
Exactly, that is the only ground.
Yeah, sorry, and I should say, yeah, so this is universally quantified, so there might be many X's here. So we'll go through some examples about how this is going to shake out in a minute. So that's the idea. And if you just squint at it, right, after a while, what's going on is exactly the same thing that goes on in the Copernican class theory. There are only really, many differences, right? But like the basic difference is we are defining things that come in different sorts, so not just classes, but relations and whatever. They're now not defined by just the conditions for being a member of the class, but by the conditions for being a ground for the proposition of the resulting type. So that's the idea. And then you need to have various other axioms. So you can prove that this theory is consistent, essentially same idea as in fine. You start out with a theory where you have no grounding relation, and then just iteratively build it up by for each class, each ground restricted formula, you can find start out with a theory where you don't have any no knowledge of the grounding relation at all, but you have an enormous amount of propositions you haven't done anything with yet. For every formula you formulate here, which is ground restricted, you just pick something new to be the resulting proposition, keep on going. You can keep on going, I shouldn't say arbitrarily far, but roughly you can go arbitrarily far. Okay. So that's the idea. So that's the idea. So why would you be interested in this nonsense? Okay, let me give you some applications. And then, how am I doing for time? I've done 40 minutes or something? Is that right?
Yeah.
Perfect. Okay. So
Actually, almost 40 minutes, like to the second.
Perfect. Okay, so I think I'll go for 10 or 15 minutes more to see, like, why is this interesting? Well, it's interesting because it gives you, I think, because it gives you a consistent theory of structure propositions. You know, and it also gives you a consistent theory of structure propositions where you actually have a pretty strong comprehension axiom, right? Because this really is a comprehension axiom for relations. So that's nice. We know they're consistent theory of structure proposition, and you can go ramified. This is not ramified. There's a sense in which maybe there's some kind of ramification hidden here, but like at least the notation is certainly, well, okay, your mileage may vary on this. I find the notation here significantly easier to think about than like ramified type theory, but you know, I'm used to this by now. Okay, but I got interested in this for a couple of reasons coming out of the theory of ground. I'm a degenerate metaphysician, so you know. So let me tell you about some of these applications. Okay, so application one. All right. So here's a question. We'll write this back in a second. Here's a question that comes up in the theory of ground. So P grounds P or Q. Q grounds P or Q. So strictly speaking, I shouldn't write like this, but that's sort of what we have. And then this is like an extremely awkward question. You know? Does P together with Q ground P or Q? Okay. So in the lingo, is disjunction amalgamating, as they say? Okay. So how on earth can we settle this? Some people think just these. Some people think this. Some people even think if they both are true, then it's not grounded in each, it's just grounded in them together, and so on. It's like a completely impossible question to answer, it seems to me. Okay, what I always thought was the right answer was like, there were just two different disjunctions. There's one disjunction which works just like that, and there's one that works like that, okay? Well, you can probably see the theory of Copernican ground we have here just gives you exactly that verdict, because the grounding profile for this disjunction is the following formula. X equals P or X equals Q. So this defines a grounding profile. So this defines a relation that holds between a propositions X and the proposition formed by applying a relation to P and Q if and only if the resulting proposition is, so the grounds for the resulting proposition are either exactly P or exactly Q. So this is the grounding profile for this guy. And then, well, same, right? But you add the clause X equals P and Q, and then you have the grounding profile for this. So you just get two different disjunctions. So I think this is great because it answers the metaphysical question. Some people think, oh, this is horrendous, because you know what on earth do we say when we say or in English? Oh my God, in Norwegian, like, could the English speakers use this one and the Norwegians use this one? Like, how would we tell? Okay, this sort of annoying semantic questions, I think I should have a better answer to, but like, you know, there we are. So this gives a kind of very nice plenitudinous answer to a metaphysical question, like why would there only be this rather than that? What could settle it? Well, nothing, because there are both. So it's kind of a standard plenitudinous move. Here maybe taken a bit too far, but you know, there we go. Okay, so that's one application. Here's another application. If A equals B, what grounds that? Okay. A good question, maybe. Silly question according to some people. What grounds true identity propositions, right? So there are many views in the literature. I think two worked out in some detail. So I argued for the view that these are all zero grounded, so they're just grounded in the empty extensional property propositions in the current lingo. Ezra Rubinstein has argued that they're grounded in the existence of A. So the existence ground identity. Okay, so you can probably see what's going to happen now, right? We're both right? Because there will just be, by the Copernican comprehension axiom, two different relations. How do they differ? Well, only in their grounds. So here's the grounding profile for x equals y and x. I'm just going to write x equals empty set, but really means empty. That's mine, right? This formula is true of A and B if and only if A equals B, and then the grounds for the resulting proposition will be empty. So that's me, I win. And Ezra, he will get this one, and x equals the existence of x. So he wins on that one. You know, so now we both win. There's no metaphysical issue here, actually. Of course, there's a good, I mean, probably not a good question, but there is a question about what we mean by equals. And there might be a better question about which equals is the best one to use. So one is metasemantic, the other is pragmatic. But if Copernicanism is right, or this version of Copernicanism is right, there's no metaphysical dispute here. So I kind of like this line, as you probably can tell. Okay, right, okay, let's do some applications. Okay, third application. So this is going to turn out to be a universal proposition. So remember, I don't know. I said, or I intend to mean that there are propositions without constituents. So they are just defined by specifying a condition on an extensional property proposition. So here's one, x equals x. So this yields a proposition that is grounded in every extensional property propositions. Okay, let's call this, so 1 for all x, x grounds 1. So the immediate grounds for the proposition 1, let's call it 1, if and only if x equals x. And this proposition is definable without any use of the grounding relation, so this guy comes up really early. So this is a proposition which is grounded in everything. It's a trivial proposition in a certain sense. Okay. This proposition, of course, now is grounded in itself. Because the extensional property of propositions 1 is, in fact, identical to itself, and therefore grounds itself. Okay. So a ground is not irreflexive. Okay. I like this because I've defended responses to issues in the so-called puzzles of ground literature, which like says, okay, it's not reflexive. Okay, so what to say about this? Okay, this is a little perverse, right? But I wanted to defend the theory. I like my own solution to these puzzles. Some people have done other things. So I just wanted to give you a theory of what propositions there are that forces you to accept my solution because your solutions aren't right. We'll come back to another one in a second about this. Okay. Okay, what's good about this proposition, though? It's grounded in itself, but it also has other grounds. Right? So Trump is president, and so the proposition that Trump is president is also a ground for 1. So it has an unproblematic, at least in the metaphysical sense, ground. You know, other things. So this is not so bad. Okay, let's see what else we have. Yes. Oh, yeah, key thing, right? Okay, good. The grounding hierarchy, this means that the grounding hierarchy is ill-founded. There are infinitely descending, non-terminating chains of ground. I think that's fine. What matters for me, at least now, is that the definitional hierarchy is well-founded. Everything is ultimately definable in a well-founded manner from things that don't stand in need of explanation. That's captured by the Copernican theory because the way we define the grounding profile, that happens through a well-founded hierarchy of orders, but the resulting grounding structure is ill-founded. That's the same thing you have in the Copernican theory of classes because you have self-membered classes, you have more complicated senses of ill-foundedness, but everything is defined in a well-founded manner. Okay. Okay, let me say one thing, two more things, I think. Then I'll stop. You can define a truth property and an instantiation property in this theory. Okay, so let's see how that works. So this defines the property that applies to a proposition P and yields a proposition which is grounded in exactly in the proposition P, or rather the extensional property that applies exactly to P. Right? So that behaves, what?
Like a truth.
Yeah, exactly, or like a truth property. So, and it behaves like a truth, so here's sort of dialectic behind this. Some dispute in the logical ground, like how does the truth of P relate to P? Some people say they're the same proposition. Some people say P grounds the truth of P. Some people even say, actually it's not P that grounds the truth of P, it's just the grounds for P that grounds the truth of P. And some people have said the latter in order to get around certain puzzles in the logical ground. Okay, so this actually is kind of ridiculous, but this is why I started this project. Because I defended a solution that sort of, no, the true story is P grounds the truth of P, and that's why you have to deal with various paradoxes in the way I like. And then people say, okay, but truth doesn't work like that. But then I say, well, it doesn't matter if it's truth. I just need something that works like this. And look, here's something that works like this. And so, you need my solution anyway. Okay. Maybe not the best motivation for coming up with a very elaborate theory, but there you go. Okay, so you have truth. Good, okay. So one final thing. Now I say like everything is great, but, well, there are problems. We have a theory of structured propositions. And they are very much structured like sentences. So you kind of should expect that you should be able to get something like a fixed point theorem or a diagonal lemma. Sketch of how to get that is on the handout, but that is in fact true. So you are, and you're going to get it in a very annoying way, for every property of propositions F, there will be a proposition G such that the only ground for G is, well, the result of applying F to G. Okay. So it's a fixed point theorem in a very strong sense. Okay, so fine. Okay, what happens now? Well, some things are not so good, perhaps. I actually think this is good for what it's worth. Let that be truth. Then you have a truth teller. Okay. Well, slightly worse, I said, and this is where I cheated along the way, negation is something you start out with. So you actually start out with having a negation property. What happens when you define grounding profiles is that you already know what the negation of the proposition RAB is, but when I know what R is, I also now know what grounds the negation of RAB. Well, that means you're going to find a proposition, the sole ground of which is its own negation. The grounds for the negation of that proposition will actually be the double negation of that proposition, and the grounds for the double negation of that proposition will be the proposition itself. So you get, within this theory, a purely propositional liar. Okay, so you get a proposition. You know exactly which proposition it is, I should say, definable very early on, which is a liar. That's something you have to deal with. There is a way of setting up this theory where you do everything. We don't do it bilaterally, and you can avoid this problem. But you still get the truth tellers, of course. Okay, let me say one more thing. Yeah, let me say one more thing, and then, two more things, very quickly. The Russell-Meyerl paradox in this theory just turns into the liar. So for better or worse, it's the same thing. That was the quick thing. The other thing is this. You may have noticed, well, if not, I'll tell you now, that all the grounding profiles I've given you so far actually don't use the grounding relation at all. They're defined just in terms of and or not and various features of the extensional property. It's not quite right because the extensional properties create some issues, but I want to end by saying something about where you might need to use the grounding relation. I'll try to make this very fast, and then I'll stop talking. Okay. What are the grounds for a universal generalization? Well, the standard view is that the grounds for universal generalization, everything is P, are the instances of P, possibly together with the fact that they're all the instances. Okay? You can write that down here. You can specify that grounding profile. Because that really just tells you, like, look at the extension. So take a property proposition, take it a property P, look at the extensional property that contains every proposition of the form P of A for some object A, and then maybe not P of, sorry, not existence of some other thing. So like, these things are P, everything else doesn't exist. You can specify that grounding profile. Okay. So you can do that, so you get the standard view about the grounds for universals actually comes out definable. It's a problem. I mean, this is not really a problem for the theory, but it's a problem with this account. And it's the hardest problem, it's the hardest puzzle of ground. I'm just going to give you Fine's version. So he wants to say, look, everything exists. It's got to be true. Okay. Well, whenever you have a true statement, there will be the fact that things are as the statement says there are. So there will be, sorry, I'm going to overload this notation now, but I'm going to use this for the fact that everything exists. So whenever something is the case, the fact that that thing is so exists. So for all x, everything exists. Therefore, the fact that everything exists. Oh shit, that's an instance of that. So the only way of grounding this is to ground that, but the only way of grounding that is to ground this, and therefore we can't actually ground the proposition that everything exists. So that's the hardest puzzle of ground. I already said I had a liar, so there will be some propositions that neither they nor their negations are grounded, but everything exists maybe shouldn't fall into that category. So what can we do? I'm not going to wave my hands at this because I've kept you here very long. Here's a kind of nice idea that I think many of us, well, some of us anyway, been tempted by. It's all on the handout, but let me say it now. So the grounds for everything exists should be some propositions x, such that no matter which object you give me, and no matter how you try to ground the existence of that object, x together with those grounds will give me something that guarantees, will give me some grounds for that object being P. So I have some propositions x. You give me an object A and some ultimate grounds for that object's existing. I'll take those grounds and my x, extract from that some grounds for that thing's being P. That will ground a universal generalization. Everything is P. Kind of intuitionistic feel to it, like, you know, I have some things such that no matter which object you give me and no matter how you show me that that object is in my domain, I take that with what I have and transform it into something that shows that that thing is P. Okay. So that's what I want to say. If you could say that, this is zero grounded, right? Because you give me an object and any grounds for that object existing, what do I have to add to that to get that that object exists? Nothing. And so if we could do this, we would get that everything exists is zero grounded and we can solve the hardest puzzle of ground. Okay, but now there's a problem. Because I said, you give me an object and you give me any grounds for that object. But now you should say, being a Copernican, what do you mean any grounds? There's no stage or no order in the development of the grounding relation where we have the whole grounding relation. So what on earth do you mean? Give me an object and any grounds for the existence of that object. Can't do it. So this nice story that solves the puzzle doesn't work. Okay, so let me just say the details on the handout. Here's what you can do. For every order O, you can define an unrestricted quantifier. I guess I'll call it pi of O, such that, let's write it like this, is zero grounded. The details are on the handout. And let me just say, what happens here is that if you know very little about the grounding relation, it's going to be very hard to ground that everything is P. Right? Because now you can only, what do I know about what it is to ground an arbitrary object? Very little. So it's be hard to figure out that that object is P. The higher up the orders you go, the easier it's going to be to ground that everything is P. But what you end up with here is a hierarchy of universal quantifiers. But what's interesting is that they're all unrestricted because they all concern all objects in the Copernican, because you have the ontology there. So we already know what all the propositions, we know the form of all the propositions, but we don't know what grounds them. So we can make unrestricted general claims already at order 0. They just turn out to be very hard to ground. The higher up you go, the easier they get to be grounded, but you still have this unbounded hierarchy. Actually, something similar happens with conditionals. So you get a hierarchy of conditionals that get it easier and easier to verify. Okay, so let me just wrap up and I'll stop. So what is this? Why would we do all of this? Well, I think, I'm going to say two things. I think I want to do it in terms of ground because I have commitments. These are my commitments. Let me do it this way. And that fulfills, I'm trying, here's the non-blank check you can now cash, because I've sort of given you this blank check about this for a long time. The other thing that I think like this Copernican approach to is just really, it's kind of not really done, and I think maybe it should be done. People who are interested in structured propositions, even if they don't like ground, I think should really have a look at this. I do it in terms of ground, that adds a bunch of complications. Just maybe do this in the same way, but now do it in terms of possible world truth conditions or something. You can still get structured propositions. It's going to be consistent by the Copernican construction. And at least we have something to show the higher order people who keep insisting that Russell-Meyer just refutes any theory of a fine-grained reality. Anyway, thank you very much. Looking forward to the questions. Let me just grab a pen, actually, while I'm
Meanwhile, I'll start taking names. I got Sarah. Ashley, Kat. We'll go from there.
yeah,
Go ahead, Sarah.
Okay, thank you so much. Before your talk, I would have always said, I know nothing about grounding, and your talk basically showed me how little I know. So, but that was really, really great. But of course, now I will ask about the bilateralist perspective. So 2 questions and then maybe a tiny follow-up. But I think you said so is it the same to say about proposition P to give the anti-grounds for P or to give the grounds for not P? And if so, if it is the same, in which which logic are we in? What kind of negation is that?
Yeah.
And the second question would be, can you give me really an example of what would be anti-grounds for, really for a concrete proposition? Could you tell me what the...
Yeah. I mean, these are entirely fair questions. Let me say, let me answer the first thing first. So, let me do this. Sorry, this shouldn't be that hard to answer. The way I'm thinking about, the way I've been doing it here, I didn't go through the details. It's you have the negation operator at the outset, so you sort of know what the negations of all propositions are, but you don't know their grounds. Okay. But there's one thing you know about the negation operation is that the double negation of a proposition will be grounded by the proposition itself. In fact, you know that it's the sole ground for double negations are the proposition itself. So what you'll end up with is it's actually a little hard to answer the question about what the logic you end up with, because like, you're actually defining like with the comprehension axiom, you can sort of define any conceivable logical operator. So what you have to do is like, you have to define some, and now you have to look at the logic for those things. But if you restrict yourself, I should have checked this, because it's a very fair question, the logic of negation, disjunction, and conjunction, sorry, that will be strong cleaning, I think, the way this is set up. Yeah. Then you can add various conditionals, and you can ask what the logic will be for those, and then that's going to be a very hard question. So that's the first thing about that. Now, if you do it in terms of anti-ground directly, then what you should say is that you already know about the negation operation, that the grounds for the negation of a proposition will be exactly the anti-grounds for that. And you also know that the anti-grounds for not P will be not P, and then that's going to give you the double negation thing. Okay, and then you just do everything in terms of ground anti-ground. Okay, but now what are some concrete cases? The vision is that for relations you define, it's really up to you, given certain constraints, right? So what I want to say, so no, I said, oh, I have two disjunctions, so how embarrassing. Okay, it's even going to be worse. I'm going to have two conjunctions, right? Because I want to say, look, the grounds for the conjunction P and Q will just be P and Q together. Okay, now the anti-grounds the grounds for not P and Q, so not P and Q, two options, either not P and not Q on their own, or not P, not Q on their own together with not P, not Q together. These are just two different relations because they have different in this case, I guess, anti-grounding profiles. And it's a commitment of the view that like that's how it goes. I guess one thing you could do is say like, no, you always have to add the amalgamating clause, and then you can make it sort of canonical. But that's not quite right, because what it, okay, anyway, I can't quite say that. Okay, for other cases now, for a proposition you find, I'm sorry I shouldn't go on so long, but for a proposition you find in the wild, like this is blue or something, so what grounds the negation of this is blue? Well, that's for metaphysics, right? You know, that's presumably at the fundamental level. We need to do fundamental metaphysics to figure out what the truth is. So the idea is like at the fundamental level, it's just fixed. I don't know. Study it. For what you define, it's up to you. That's the vision. Sorry, I'm going on too long, so sorry.
That's fine.
Yeah.
I think we have Axel next.
Yes.
Well, yeah, go ahead.
This I think is partially clarificatory, at least. So when you were giving the second of your applications, you're talking about the identity case, and you pointed out that like on your view, actually what we get is just like two different understandings of the grounding of identity and let 1,000 flowers bloom. What I thought you would say there initially was like, hey, look at me, I get to do this without an existence property. But the Rubinstein one needs an existence property, boo on that. So I think that, so then I was like looking through the stuff we didn't go through over the handout, and you talk a lot about the existence property, and use it quite a bit there. So I'm wondering, like this is not something that I have like a big dog in the fight for, but I'm curious, do you need to render as a property existence in this view?
Yeah, great question. And like maybe so. As far as the Copernican like construction goes, like definitely no. Adding it in just makes life harder for me. But here's why. So this is like first order metaphysics why I want this. So let me answer that. But like, yeah, maybe I should just take it out for the purpose of the construction. Okay, so I'm kind of like the view that there are certain generative operations that apply to some things and gives you something else. The generative, so here's an example, set formation, fusion formation, and so on. How do these operations work? Well, you define them by specifying when they can be applied, when the things you get from applying them exist, and then some other stuff about them. So there I said exist. So do I need an existence predicate as opposed to just identity and existential quantifier here? So I think I do, but like, and the reason for that just has to do with sets of incompossibles and other stuff like that. So I kind of like the view where if I take, so I have two, I don't have any sisters, but I might have had sisters. In fact, there are two possible sisters I have that couldn't coexist because they come from the same egg, you know the story, okay. But now I think, look, I know perfectly well what the set of those two incompossible sisters is. It is the set that has this member and that member, but I also know that that set couldn't exist. So I just wanted, so that's the kind of reason why I think I want an existence predicate. But if you hate that metaphysical view or views of that sort, I think, yeah, what you should say is like, just why do you make life hard? Because now you have the existence predicate. But in some, okay, so that's the answer. But in some sense, like, maybe what I should say, I don't have to do it with it. Probably I shouldn't do it with it. I should say, like, you can add it in, and if you add it in, then somebody like Rubinstein now has the stuff available within the Copernican view to get his relation too. Of course, it's like worse than mine, but it's still a relation, right? So that's what we can say. Anyway, does that help?
Yeah, no,
Yeah. But I actually haven't thought about it the way you said. I think that's very helpful for me because now I'm tempted, like, so many moving parts. Why not take away this moving part? Anyway.
Well, then you can say, I'm the only one who has an answer here.
Yeah, but I don't believe that. You should say what you believe. But anyway, thanks. That's great.
Into how bad you think or how wide you should work out the two conjunctions and the two disjunctions and the two identities. Yeah, but at the philosophical level, right? Because propositions it's a technical term, right? It's supposed to do some job, and I'm afraid that if you have two different disjunctions, proposition won't be able to do the kind of content in it.
Yeah, no, absolutely. Okay, so what do I have to say about this? Okay, this first thing is a cop-out to some extent, right? So I use propositions because, well, I like that. But if you don't like that, I think like states of affairs or factoid or something might be the better. You can do that. So now the question is like, is there really a different state of affairs with these two disjunctions? And I kind of feel like I know what makes them different. Their grounds. So that's kind of what I want to say at the worldly level. At the level, so maybe what's going on is like, okay, let me say two things. The things I call propositions here are sort of not fit for purpose in two ways. This, I'm not sure I believe this, but let's push it. One is the reason you give. They're too fine-grained, like, Jesus, like two disjunctions. And the other way, they're not fine-grained enough. Because these function like Russellian propositions. So if you want propositions to be so fine-grained to get Hesperus versus Bright, be distinct from false versus Bright, I'm not helping you. So like maybe the word proposition is not ideal for what I want here. So yeah, what?
What is it that you're doing?
Yeah, no. Then I think like so change it to states of affairs. So I should have said this earlier. Actually, I wrote it on the handout, but I forgot to say it. So I'm actually using kind of precisely because of the Hesperus versus Bright, false versus Bright case, like proposition here is used for what is the case, not for how what is the case is represented to be the case. So this is a little awkward use of proposition, but you find it in Russell. And I think Stolnaker also uses it in this way. So it's a very fine-grained conception of proposition in that sense. So I think the semantic worries are a little less extreme if you, a little less pressing here. There's a good question now, I think, like, okay, so what do I express when I say P or Q? It's raining or it's sunny. I think the natural thing to say is that you express a bunch of these guys, and it doesn't matter. But the semantics, or worse perhaps, the meta-semantics of sentences involving the word or in English is something that needs to be worked out for such a view, for sure. Absolutely.
Yeah, but that's actually going to be the second question.
Yeah.
Like, how would this be implemented in semantics? But yeah,
Yeah. Okay, let me say one quick thing about this, and this is lame, and I'm not sure I believe it. Anybody who likes a plenitudinous view, say in like material material objects ontology, is going to be stuck with exactly the same thing. And like, am I happy with their solutions? No, I'm not sure, but I'm going to deflect to them for the time being. Yeah.
So we're actually doing quite well on time. So if anyone wants to squeeze in any final questions or comments, yeah, go ahead.
Yeah, I'm good.
Yeah.
Perfect.
I wanted to ask. I couldn't follow all the details of the theory. If you have, can you have the can you define the a proposition like something grounds something or everything grounds everything?
No.
I got lost in the
Yes.
when you
No.
talk about the quantifier. So it's
Yes. No. So good. So propositions formed using the grounding that involve the grounding relation itself, you cannot form because things that count as propositions by the lights of the theory are things that are built up of things that come at certain orders in the hierarchy. The grounding relation itself never shows up at any order in the hierarchy. What I can do is I can define like ground at ground, sorry. I mean, this is not how you would write it, but like the grounding relation restricted to order O actually should use that, sits at order O plus. So I can say something like, this will be false, but I can say everything O grounds itself. That I can, there is such a proposition, but there is no proposition of the form something grounds something. But there will be various, as it were, order restricted versions of that. Yeah.
Philosophically, so the objective is to build all the with ground conditions, all the propositions that don't involve the notion of grounding.
Yes. And well,
whereas because the yeah, no, I don't have a. So the philosophical picture is that this is an important class of proposition, and the one that involve grounding get a different treatment. I'm just wondering about.
No, I mean, I think you can put your point in a very sharp way to me, so I'm going to do it for to myself. So I can write. So I was kind of lackadaisical, but you can write down a theory of this, right? So in that theory, this sign here occurs an awful lot. That, by the lights of the theory itself, there is no relation such that, you know, you can prove, in fact, right, it's a, okay, so you can prove within the theory there is no relation R such that for all, I guess, for all X, for all Y, or that way, X, sorry, this is not quite the right way of doing it, but fair enough. Rxy, if and only if X grounds Y. So, yeah.
The theory doesn't entail the unnegated part,
No, I bet it.
The theory entails the negation.
Yeah, it entails the negation. Because this is not the quite, because if it did, because if you had such a thing, then it would have to occur at an order. And that meant that at the next order, you could define Russell. So yeah, so you don't have this. So the sharp version of the worry for me is like, wow, you have this lovely theory about propositions, but by the lights of the theory itself, the statements of at least some of the statements don't express a proposition. So that is that is honestly the sort of revenge worry for the theory that worries me a lot. It's the same problem. Fine's theory has the same problem. It's a theory about membership. By the light of the theory, there is no class that codes up membership. So there's no membership relation according to Fine's theory, even though it's a theory of membership. So I owe you a story. about what's going on when one asserts the sentences of the theory, because by the lights of the theory, there's no proposition that they express. Here's a story. I'm not sure I love it. There is a whole range of propositions that are expressed by any utterance of the theory, because it is consistent that there are, you can find like, just kind of like you can have reflection principles in set theory, so you can get like models of set theory with certain cardinals. You can find, on certain assumptions, you can find models of the theory within. There are propositions such that they sort of code up models of the theory. And then you can say, well, what goes on when I assert a sentence is that I assert all of those. But it's not super satisfactory because there's another revenge issue coming, like reflecting on that, but that is something you could say. But that's sorry. There's a hard point. There's a hard issue for me here.
You raised your hand.
Yeah, this is a clarification question.
Yeah.
It seems to me that there can be puzzles involving propositions and truth, very similar to this. I don't know if you tell. In the sense that a true proposition is grounded on the proposition, and then vice versa, you can say, right?
Yeah.
But then you can have some ways out of these puzzles by saying, no, the right relation between these two things is not grounding because they are identical, or maybe you just require some other grounds for both things. First, I want to know if that is the case, if there are puzzles around that area. And the second question, if those are puzzles that have concerned some people at least, how similar and how different can be the solutions for the universal puzzle of ground and for the other puzzles, if you can solve them by probably the same strategy? Or
Good. So I want to, good, excellent question. Let me answer it like this. So there are, the theory actually creates a truth teller within it. So that's a puzzle like, let me tell you how I solved that later. This is like Stefan Kramer's simplified puzzles of ground. Something is true. Well, that's grounded by itself because this is a proposition which is true, so it's an instance of itself. Okay. How do I solve that? The way I've always liked to solve this puzzle is to think like when you want the ground to be irreflexive, what you wanted is that every proposition which is in fact the case should be a non-circular way of grounding it. And that there is in this case. I always sort of, my view is that the problem posed by these puzzles is like how can we extract an acyclical notion of ground from a situation where there are lots of cycles. So here you have a very like simple cycle like this, but this is also blessedly grounded in 0 equals 0, and that's fine. So the way I looked at the puzzles is like you have a structure where you have cycles, and the problem is to extract non-cyclical information from that. Those solutions still work. In some sense, what I think of the Copernican approach to be is like, how do you get the cyclical structures in the first place? Let me tell you, here's how we define them, and then once we have them, we can extract an acyclical notion. Okay, the problem with the universal puzzle of ground is that there you, on the standard view of the grounds for the universal, there is no way of grounding it except cyclically. And that's why you need this more complicated one. Okay, the grounds for the universal. So now we get a cyclical root still, but we also have the acyclical ones, and so the solutions I like earlier, are still there. Okay, so that's the thing. But unfortunately, part of the commitment of the theory is that I get worse puzzles, because now I have a good ground. Here I always had a good ground, but the theory now creates propositions where there are only bad grounds. Because you have the truth teller, let's call it L, I guess, which is solely grounded in L, and then the structure sadly just looks like this. And once we add negation in the way we should do it, there's no help there either, because let's write it like this: the negation of the truth teller is just the negation. It just goes like this again. So no good. So here we have a very bad situation. Okay, so let me say, if there's time, I'll say something about what you can do here. Okay. Once I have the truth teller, I know exactly how it's grounded. Because it's grounded in this and not grounded. There's nothing more to say. So now I can define, it's not negation, but I can define something else. Suppose I knew what the fundamental propositions were. God told me. And then I could now actually see that there are no grounds for this proposition, nor are there grounds for that proposition. So I could introduce, it wouldn't be negation, but it would be something negation-like, is impossible to ground in the fundamental. So I could internalize isn't ground. I can define a property which applies to the proposition if neither it nor its negation is grounded. At an order though, right? So with the truth teller here, I can do it very early. But what I can't get is a property which applies to a proposition if and only if it is not grounded full stop, because that would require knowing the whole grounding relation. So what happens, so this is actually what happens with the liar or the Russell-Meyer thing too. I can actually just say, I know exactly how that proposition works, and I can say, no, neither it nor its negation is grounded. I can say that. So I can internalize some things. Okay, does that help?
Yes.
So there's still going to be there's still going to be problems, but there is actually within the theory quite a lot of resources to say nice things about the propositions that are pathological.
Okay, thanks.
Yeah.
So, Axel, you had a final.
It's a long question, so I don't know if you want to just say goodbye to yesterday.
Would it take more than 5 minutes?
To get a response?
Yeah, you'll take the whole entire.
No,
Just
I'm not
go
gonna
for
do
it.
okay.
You're-
Yeah, yes, okay. But this has a lot to do with my ignorance, right?
Mhm.
So I still don't see why the problems that this junction has do not extend to every binary relation, right? Because I think.
Yeah, they probably. I mean, you're gonna be not quite, but essentially it's really bad. If a binary relation is such that it has a unique ground, then the answer is canonical.
Yeah.
But interesting cases won't be like that. I agree.
Yeah.
So I have a problem.
Not only propositional,
Yeah.
but
Yeah, I am taller than you, if it's true, has many grounds, and there will therefore be many propositions taller than that differ only in the grounds for how they are instantiated. Yeah. So yeah, there's definitely I gotta say something about the semantics at some point.
Okay, good.
Yeah, no.
Also, your paper on generalizing isn't out yet, right?
No, it's not out yet. It's not out yet. Yeah. We'll see. It's somewhere. Yeah. I'm happy to send a copy to you.
Oh, yes.
Yeah. So I'll have to ask my co-author, but yeah. But I'm sure that's fine.
Okay, so that seems to have worked out pretty nicely.
Well, I don't know, but thank you anyway.